10 line, then one semester gone, second semester, 2 months, finally end up. I'm not telling everybody because I don't know what you are doing. You are able to start the event project on itself. I'm just giving a maybe a warning, feedback from previous batch. So start working from day one. Every day work little bit, incremental, correct? See, another thing is these full-time students themselves are struggling. They don't do initially, they leave it. But you are working and sometimes your work pressure will be there some month, some weeks. So if you plan work something or weekends, you can work on it, your projects. So otherwise, it will be really tough. That's nothing more than that. I think many students join. We will start the class. Okay. Yeah. So I think I stopped in the previous slide. This slide, what are different type of hybrid vehicles. Please note that this naming convention is not some standard names. It is across different companies by societies like SAE or companies or consortiums. Together, they coin these names: mild hybrid, micro hybrid, mild hybrid, hybrid PHV, all these names. Okay. Now we are going to see a little more deeper how they classified, what is the basis, why the name has come. Start with first type, particular micro hybrids have a degree of hybridization less than 5%. That means 5% will be the power supplied by motor. 95% coming from ICE. If vehicle has 100 kilowatt power generating, 5 kilowatt is generated by motor, remaining 95 kilowatt IC engine. Please note that this is sometimes some book they may say 10%. Correct? They may say 10% is called micro hybrid electric vehicle. Exactly, there's no hard and fast rule. Approximately only. That's what I'm saying. Generally, it is accept a 5%. I took it from some reference books or something. So if you do again tomorrow, some books say the micro means 2% or 8%, 10%. This is what it is. That means hybrid contribution of electric vehicle is very less. This talks about electric vehicle contribution, remaining this one. The electric motor in the form of small integrator starter motor generator. Please note already you have alternator, correct? Alternator, we know that it can be used as a starting motor and the same thing can be used as an alternator also. When engine is running, it will generate power which can be used for charging the batteries. Correct? And while starting the vehicle, it is used as a starting motor. Used to shut down the engine when vehicle comes to a complete stop and a startup when driver releases a brake pedal. Once in motion, vehicle is propelled by the IC engine. EM does not provide any additional torque. In micro hybrid, it is only during starting time or this one, but as per the vehicle, this one is a propulsion is concerned. It is done by IC engine. That if this kind of vehicle is called still a hybrid vehicle because there's an electric generator motor which is a part of the vehicle, so they're called micro hybrid. Okay. Fuel efficiency by using this small electric motors, this one, the fuel efficiency of the vehicle can be increased from 5 to 10% depending upon how this one different manufacturer differently adapting. So this is what they say. Between this, it can provide by use of this electric motor. Okay, we call them micro hybrid. Then next one we call mild hybrid. Correct. The second one will have higher capacity motor, electric motor, up to 10%. Because here there's a 5%, here 10% power is provided by electric motor, remaining 90 will be provided by IC engine. And a battery which permits power resist during vehicle propulsion. Okay. The small motor is only during that is acceleration during that time, something that it can assist little bit. Okay. The typical fuel efficiency, because you are using electric motor, then engine power is reduced by 10%. So then you will get a fuel efficiency can increase from 20 to 30% also in some vehicle. Okay. When compared to now just pure IC engine based vehicle, 100 kilo IC engine based vehicle, and you have a mild hybrid in which the electric motor provides 10% of the power needed, then it can get 20 to 30%. Someday it can be 15 also. Because please note that these numbers or not, because there are more than 100 different companies making vehicles around the world, right? Even more car, truck, all those things. So this is only a approximate value. Advantage this one. Then we can talk a full hybrid electric vehicle. HEV hybrid electric vehicle uses bigger and powerful electric motor and battery. Bigger means, for example, I said 100 kilowatt vehicle means whether 40 kilowatt motor, 60 kilowatt engine, or 50-50, correct, or 60 or 30-70, some combination, but it is not like 10%, correct, like 5% in micro and mild hybrid. Here it has, it can go up to 50-50, 40-60, 60-40, something like that. Depending on the vehicle power demand, the electric motor can be used as a source. Sometimes, please note that the electric vehicle motor alone can be used. We are going to see that because we know that depending upon driving mode, correct, driving scenario, whether the vehicle is inside the city where pollution should be reduced, correct, frequent braking, and this one we start and stop, correct. You cannot go beyond some few kilometers, 30 kilometers, 20 kilometers to high traffic, sometimes even 5 to 10 kilometers speed only in city traffic. That time, the electric motor is the best compared to IC engine. Correct. We know that when you run a IC engine at a low throttle condition, correct, idle condition or 10%, 20%, 30% throttle condition, the emission is extremely high. In ideal conditions, even 10 to 15 times more CO is HC is produced in petrol engine. When you are driving a low throttle condition, in city condition, that's what happens. You'll be in first gear, something, your throttle, you cannot accelerate, you'll drive in 5 kilometers, 10 kilometers. That the best thing is to use electric vehicle, electric motor. In the hybrid vehicle, it is programmed such that the ECU which control engine and the motor will program such that whenever the vehicle speed comes below some limit, if battery power is available, sufficient energy is available in the battery, then the engine will be shut off and the electric motor will be purely used for driving the vehicle. City low speed, which happens only in city. When you go to highway, your vehicle will be cruising 50 to 60 kilometers, 70 kilometers or higher speed. That time, IC engine will be used as a sole power, because cruising condition engine offers the maximum thermal efficiency, less emission. So that time, shut off the motor, keep it the electric power for city driving, use in highway IC engine. So more change will happen. Compared to micro hybrid or mild hybrid, the full electric is a much small engine, generally bigger electric motor. As I told you, the 60 to 70% will be the can be. Please note that, so don't say my company is making 50-50, so you say 60-70. 60-70% will be the motor, electric motor power generation. Remaining 40 to 30 will be IC engine. Correct? The contribution of the power to the vehicle or to the supply to wheel. The fuel efficiency increases full, that is hybrid vehicle, full hybrid vehicle, around 30 to 40, 50% in the actual vehicle compared to non-hybrid, that is pure AC, because most of the time you are driving with a bigger motor and most of the time. Right? So that means automatically you drive the IC engine in cruising condition, highways. Correct? Highways, cruising condition. That time you will operate your vehicle at mid-throttle condition. Correct? Mid-throttle condition, the fuel efficiency very high, thermal efficiency very high. You are not going to apply brake frequently because highway you are driving. All this thing. And engine speed going to be a constant speed. And you will be, most of the time you will be operating at max torque condition. Correct? Engine will be operating max torque with the proper gear. So cruising condition, not at a full throttle condition, correct? Or a low throttle condition. So that's why the fuel efficiency can increase 30 to 40% from the non-hybrid vehicle. 100 kilowatt IC engine base instead of 100 kilowatt hybrid vehicle, in which 60 to 70% of power is coming in electric motor remaining. In that case, you can get this much this one. That's what the other one is called plug-in hybrid, correct? PHE they call, similar to full hybrid. Okay, configuration same, bigger electric motor, smaller engine, sometimes much smaller engine compared to full hybrid vehicle. Maybe 80% power coming electric motor, 80 to 90. Very small engine, correct, for charging, but all this will be one thing. Additional provision given for external. Main thing is here, you PH means plug-in hybrid means you can, there's an engine and also there's a socket for charging the battery. Correct? That is what plug-in hybrid. In the electric hybrid, fully all those things, charging the battery is done by engine itself. Mild hybrid, correct? Micro hybrid and full hybrid electric vehicle. The battery charging is done from the engine which is driving a generator, correct? Power generation, that the increase. But in a plug-in hybrid, you are going to charge the battery from the external grid power supply. Okay. So the bigger electric you have, generally very big motor, even bigger than the full hybrid. PHEV, maybe 90% of the power will be coming from the electric motor, and which is powered by a battery. Of course, there's a battery that will be charged from the external grid, not by the engine while it is running. Then downsize engine, the small engine, owing to high electrical component, PH can run on electric power for a long period, because as we told you that just now I told you, if it is a full hybrid also, in highway you'll be driving with IC engine. When you come inside the city, it will be driven by electric motor. Okay, so to reduce pollution, slow speed, starter, all those things. But in plug-in hybrid, the engine will be very, very small. Majority of the, including city drive, everywhere you will be driving with electric motor. That's owing to bigger capacity. The motor will have 90% of the power requirement of this one. So we can say that it is almost like a pure electric, close to pure electric plug-in hybrid. But it has small engine. Suppose the engine, this is the battery power is that the small engine can be used to charge your battery. So again, you can come back to nearest charging station. That is the advantage of plug-in hybrid. Okay. Now, when we talk about hybrid, already we saw that the hybrid is classified like this: pure IC engine, pure electric vehicle. This is a fuel cell. These are both are same. Both are pure electric vehicle. The pure IC. In between, you have the classification which we saw. Okay. Now, what do you mean by hybridization? There's a definition. We say that my vehicle is 10% hybridized, 20% hybridized, 50% hybridized. That means my vehicle has both petrol engine as well as electric motor. How much power is coming from electric motor? How much power is coming from? That is what there is a hybridization definition. That is generally say hybridization is referred, if you refer to H, equal to sum of the power of all traction motor. Correct? That means electric motor which is driving the wheels. Sometimes you have motors for driving some other part of the vehicle, that is not considered, only traction power divided by total power of the vehicle. For example, I said that I have 100 kilowatt. 100 kilowatt my vehicle power, which is motor plus this one. Out of that, say 40%, 40 kilowatt is from the motor, 100 kilowatt the total for this one. So the hybridization is nothing but 48%, right? 40 divided by 100 multiplied by 100 is the percentage. Okay. Generally, you say 0 to 1. Hybrid H value will vary from 0 to 1 in percentage multiplied by 100. Correct? So if I say bigger the number of H, I know that my vehicle has bigger motor compared to engine. Engine is smaller. When I say 100, it is become 1. Multiplied, that means it is a pure electric vehicle. When the H equal to 0, I say that it is a pure IC engine based vehicle. Okay. The battery efficiency is moderate. Energy lost is putting energy into the battery and again removing the energy. Round trip in and out efficiency, typically this kind of hybrid vehicle, generally you know that, as I told you, hybrid vehicle, you have an engine, you have an electric motor, EM, I say this is ICE, both are connected to a mechanical element, which in turn is going to drive the wheels. Okay, these are wheels, two wheels, and the drive, correct? Now, what we are saying is the engine may contribute to driving the vehicle, or it may run a generator and charge in a battery. A battery pack is there that will be charged by the engine, which in turn will run the electric motor. Right? So the battery efficiency, because here in the hybrid vehicle, except the even plug-in hybrid, we are going to charge the battery from external socket. Correct? But in case of mild full hybrid or this one, we will be charging the battery using engine only. Correct? Charging battery is mostly done by engine, not from external plug-in. Okay, there's no provision. So round trip in case hybrid vehicle, most of the hybrid vehicle, depending on whether it is a micro to full hybrid vehicle, the maximum trip efficiency is 70 to 80%. Because of inefficiency, battery must be cooled. Because we are saying that we are not touching full percent. Main problem is the battery also. See, you are generating running an engine, correct, and charging the battery, correct, by driving a generator. So then you are consuming the power back by using a motor. That means generate electrical power, store it, again bring it. There are losses, correct? So battery has losses, generator has losses, because then electric motor also has losses. Instead of directly running, I run the engine, generate electric power, charge the battery, again run the motor. In a hybrid vehicle, that happens. Because of that, power is transferred from one device to another device, again brought back to this one. So lot of losses are there, energy losses. Because of that, maximum efficiency, energy efficiency of the hybrid vehicle can vary from 70 to 80% depending upon design, all those things. So the overall hybrid philosophy has 3 parts. What are the 3 parts? Correct. So you can see here, when we talk about this one, first we talk about parallel. We will see different type of hybrids today, but first we'll start with parallel hybrids design with varying hybridness. Correct. So you can see that this graph shows hybridness. So this is zero hybrid, means that means pure engine. Engine is driving. 10% energy is given by engine, and that means 0% hybridness. As the black line is going ramping up, if I come to this end, this is our right side, this is left end of the graph, this is right end. Right end, the hybridization is 10%. That means it has become pure electric vehicle. It is driven by engine. Please see that there's engine. I say a vehicle has 100 kilowatt power was needed to drive the vehicle, right? So I will have an engine with 100 kilowatt. I will have an electric motor with this one. But taking different amount of power to drive the vehicle, I can say that hybridness varies from 0% to 10%. If it is 0%, the vehicle is driven by IC engine. The 100 kilowatt power is given by IC engine. Here, gas engine means petrol engine. We are talking gas engine. You know, US they call gasoline or gas engine they call, that means petrol engine. It provides. At that time, the motor doesn't provide any power, 0 power. I say hybridness is 0% or 0. When I come here, H equal to 1. That is multiplied by 100%. So in that case, it becomes pure electric vehicle. In between, you can have. Correct? So you can see that. Okay. So parallel hybrid means I have electric motor 100 kilowatts and engine with 50 kilowatts. Please, I told you that many hybrid vehicle, more power will be coming from electric motor, less power will be coming from IC engine, and both are connected together and driving the wheel. Please know that there's a coupling mechanism or gear mechanism which connects both engine and take the power from both. It is given to the wheels. This is given to wheels. So this we call a parallel hybrid. Both are operating. Okay. So now we can say that, see this figure here, my electric motor is 20 kilowatt and it should be around 25. Sorry, it should be 25. The engine is 75. The hybridness is 0.25 because 0.25% is 25 divided by 100 together, correct? 25 divided by 100 is the H. H for this combination is 0.25 or 25%. When you come here, electric motor, this should be 75. Okay, sorry, small mistake, 75. This is 25. So 75 divided by 100 equal to 0.75 is my H hybridness, or in percentage it is 75. Correct? So this is how we define the hybridness. Okay. This is called parallel hybrid. Please note in parallel hybrid, you have both. Correct? Motor plus engine. Motor plus the only thing is degree of hybridness is varying. This is 50-50. Correct? And this is 25-75. This is 75-25. This will be this one. So this is 25. This can be, sorry, this is 50-50. Mid position, correct? So both are equally contributing. That is parallel hybrid. In series hybrid, please note that you have an engine. Engine is not driving the shaft generally. In series hybrid, it never drives the wheels. So it drives a generator. Generator generates power, which in turn is going to drive the motor. Correct? The power generated by the generator will be used for driving the electric motor. Okay. This is this is a mixed hybrid. Okay, this is a mixed hybrid. Series hybrid shown here. Okay, series hybrid. So this one still you can see the engine, generator, and a motor together. They are coupled with this one and driving. 100 kilowatt power is shared between the IC engine and this. And okay, so that is going to drive. That is called parallel hybrid. And when you come to series hybrid, what will happen is you have engine. Engine is 100 kilowatt, which is driving a electric generator, which is 100 kilowatt. That power is given to 100 kilowatt motor. So here the wheel is there. So here I have the wheel. This is series hybrid, right? Engine never drives the wheel. Engine drives the generator. Generator drives the electric motor. Electric motor drives the vehicle. So this is called as series hybrid. Series hybrid and these derivatives. Correct? There are derivatives. See, these are just a series mixed hybrid. Correct? This is pure series hybrid. This is called pure. It is not pure this one. It is series plus parallel together, mixed. Please note that engine drives the generator. From here, it is driving the motor. Motor drives the wheel, and also the engine provides parallelly 60 kilowatt power. I need 100 kilowatt. Out of that, 60 kilowatt is provided by the motor, mechanical power directly. You can see that shaft, and it also drives a generator, which produces 40 kilowatt, which in turn is given to electric vehicle. So that means if you see here 60 kilowatt coming from engine, 40 kilowatt coming from motor. Both are connected to a gear mechanism which drives the wheel. This is called series mixed hybrid. This is series hybrid. Engine never drives the wheel. Engine drives a generator. Generator drives the motor. Motor drives the wheels. Right? This is called series hybrid. So that is what is shown here again. So you can see here similar to previous graph. And again, another, this one is called range extender, correct? We saw the range extender hybridness when we talked about range extenders, REE, correct? Range extender electric vehicle. That's what we are talking here, correct? You have a battery pack of 70 kilowatt, engine, which is 100 kilowatt, generator, which is 100 kilowatt. From here, the power is coming from battery and also from generator. What this means, range extender means, normally the motor will be getting power from the battery, majority of power. Okay. Now, if the battery power comes to lesser and lesser after you drive 100 to 2 kilometers, at one stage the battery power will become very less. That means you are not getting. In that case, the engine will kick in and it will start driving the generator. Generator power will be given to motor. And so that means if battery is depleted, you need not worry. You have an engine, which is the fuel tank, and it will drive. And from the generator power comes motor drive. Please note that this vehicle is driven by electric motor only. Engine never drives the wheel. The engine is used for generating power and drive the motor whenever the battery power is depleted. That's why this is called a range extender. For example, I have battery. With battery, I am able to go 300 kilometers. After that, regular electric vehicle, you have to stop. But in case range extended, you have an engine which has sufficient power to drive a generator, produces sufficient power to give electric motor. So this one, so you can drive how much fuel is available in the vehicle, correct? Fuel tank. That may give another 200 to 250 kilometers. So this is called as range extended type of hybrid vehicle. Okay. The series hybrid, a derivative related hybridness. For H less than 50%, series hybrid morphs similar to mixed hybrid. This is called mixed hybrid. It is a series hybrid because you have a generator which is going to generate power, which is driven by engine, which in turn drives the vehicle, but it is not pure series hybrid. Okay, that's why we call it as mixed hybrid. And here hybrid has 50% only. Right? The electric motor provides only 50% of power, remaining power coming from engine. That's why this one. For a hybrid greater than 50%, series hybrid transform to range extended. This one, correct? H is greater than 50 means also region of plug-in hybrid. I told you, plug-in hybrid also, plug-in hybrid is actually electric vehicle. Engine is used for charging the battery. Correct? Basically, the electric vehicle. Okay. So, as we saw from the previous graphs and all those things discussion, typically currently available hybrid vehicle can be classified as series hybrid, parallel hybrid, series plus this one, plug-in hybrid. These are the four widely used combinations. Okay. So, this figure, already we saw the figure. This I took it from internet because you have three types of vehicle. Okay, you can see that there are three types of vehicle. Okay, this is parallel hybrid vehicle. Okay, in which engine and also electric motor. Correct? There are two. Both are. This is a gearbox transmission element because engine needs a gearbox. It has engine gearbox which is connected to a gear. And electric motor also, you can see that it is connected to same shaft, which in turn driving the wheels. Both are driving. Any given time, motor also will supply, the engine also will supply power to the wheel. How much power each is sharing depending upon the design. So this since both are supplying power to wheel, we call it a parallel hybrid. The engine gets power from fuel tank. Correct? Fuel tank. This electric motor gets from the power from battery. Battery is called DC power source. All of us know. So the motor can be, we are going to see it later, maybe after the midsum exam, different type of motor. It can be AC motor also, like induction motor. Right? It can be AC induction motor or synchronous motor, AC synchronous motor or BLDC motor. BLDC motor, DC motor. Brushless DC motor. Please note that DC motor, general common DC motor, we are going to see that you will supply constant DC voltage from battery. For example, 12 volt DC motor means you will supply 12 volt from your battery pack. So the motor drives and takes current and generate power. But in case of, but please note that DC motors are not efficient. Lot of issues with DC motor. But please note the first motor, electric motor invented was the DC motor, not the AC motor, induction motor. Induction motor was invented by Tesla. Okay, AC motor. Before that, DC motor. But DC motor have a lot of disadvantage compared to AC motor. That's why they are not widely used nowadays. But initial all electric vehicles were using DC motor with a lead acid battery. Now we are using lithium ion battery with BLDC motor, or BLDC motor require power similar to AC motor. So you need an additional circuit, what we call an inverter. That's what is shown here. From DC voltage, it is converted into AC voltage and supplied to motor. The motor can be DLC, BLDC motor, or AC induction motor, or AC synchronous motor. All three requires not constant DC. a varying DC, correct? So alternating current that is produced by inverter. So if you see a parallel hybrid vehicle, so this is electrical part, this is IC engine part, together the driving wheel. That's a parallel hybrid. How much power depends upon vehicle design. In series hybrid, you have engine. Engine drives a electrical generator. Electrical generator power is supplied to inverter. The inverter also gets power from a battery. Okay. And finally, the power from battery or from generator goes to electric motor, which is going to drive the wheels. So that's why it's called series drive. Power from here, it goes to like this. So engine power, engine never drives the wheels. It always drives only the generator. So this is called as series hybrid. Anybody have an idea? The series hybrid not only is it is there almost for the last 60 to 70 years. You would have seen somewhere. Anybody? Series hybrid already there.
Locomotives engine, I think.
Yeah. Diesel electric, not electric. It is called diesel engine. No, diesel engine we call diesel locomotive engine. Correct? So what you see in railway station go, you will be. It is there for last 60, 70, 80 years. Correct? It is nothing but series hybrid. Engine, you go and see the electric because I many times watch it, even when I was a school kid I used to work. So it will be running at constant speed. Engine will be driven at constant speed, at max torque mode, constant speed, max torque mode. Correct? So then it drives the generator. The generator produces electric voltage that comes to inverter, or it may go directly to induction motor depending upon design. And in the electric vehicle, you have battery also. So this is series hybrid. And next one is combination of this one. Again, you can see that you have engine and you have a planetary gear. From planetary gear, some part of the power from the engine goes to generator, and which in turn goes to inverter. From that, it comes to motor, and also from battery pack, power is coming. So power can be coming from engine. And please note that here, the not only charging, it can drive mechanically. Please note that this particular hybrid configuration, mechanically also it is connected, electrically also it is connected. IC engine is going connected both way. Electrically means the engine will drive generator, generator will produce electric voltage, that voltage will be given to inverter, which in turn can be used for charging the battery. Simultaneously, it can be used sent to the electric motor. And also from the battery also power can come. So electric motor also driving, the engine also driving, but please know the coupling is slightly different than this coupling, correct? So some part of power goes to mechanically to the wheel, some part of power from the engine goes to generator. This combination also very popular. It has some advantages, but because of that, some vehicle manufacturer are using this. Okay, so when we saw about, let us start with series hybrid.
Sir, what is that configuration called? Mixed hybrid or what?
It is called mixed hybrid.
Okay, sir, fine.
It is called mixed hybrid. You cannot say series parallel because engine is driving wheel also, and also the driving generator also simultaneously. Okay, so the series hybrid system.
Yeah, I think Honda City is using this technology only.
Probably. Yes. There because each car has some advantages, so that's what we are seeing. And
but in Honda City, they also cut off the engine after under a below speed, right?
Yeah, that's what I told you. No, under some speed the cut off. That means already you entered the city. If your vehicle speed, that means driver is now not pressing the accelerator. He is at 10% throttle, 20% throttle. Because throttle says what is the power you are expecting from the vehicle energy source, whether engine or motor. Based on that, the ECU decides, hybrid vehicle ECU decides, if the vehicle speed comes below some 30 km, 40 km, that means you are in heavy traffic in highway or you are inside the city. That time engine performance is very bad. Too much pollution, correct? Losses are more. and you gear loss, all the things, best thing is driving electric motor. So automatically switches, that is the controller job. It automatically switches to pure electric. Whenever the vehicle speed comes, that means automatically know that in highway, you are in traffic jam or you are inside city. Inside city, you cannot go 100 kilometers, 70 kilometers, 60 kilometers. It knows that. So that means it is programmed such that automatically electric motor is used. But if electric motor battery power is depleted, it will start the engine. That also you will do. You are driving, because suppose I am in Bangalore, correct? 2 days before I was in Bangalore. Literally, I was struggling. I was driving my car. To travel some 8 kilometers, it took 2 hours. Or at least 1 hour, 48 minutes. Correct? So, it would be better to drive with the electric motor, but battery power is limited. Correct? Initially, the hybrid vehicle will start using electric motor when the vehicle speed is below certain speed. But by the time when suppose your two traffic and to take all the power is exhausted from battery, automatically engine will kick in. Without it won't even ask. That's how it is programmed. Right? It happens. Okay. So series hybrid layout is this. Right? So you can see that you have the IC engine. IC engine is driving a electric generator. Okay. And from that means the electrical power is coming out. It comes to power unit. Can be inverter. Correct? From the AC to DC or DC to AC, depending on whatever generator. Please note that the generator can be AC generator or it can be DC generator. But nowadays, DC generator not are used. Like similar to DC motor, nobody using DC motors is obsolete because it has a lot of losses. Anyway, we are going to talk about motors around 10 to 12 hours, different type of motors, but are starting from basic motor to BLDC motor, right, and induction motor, synchronous motor, how they are working, and which is used. So DC motor, GT, they are using AC motor. So the generator can be most of the time be AC generator because there are less losses, higher efficiency, better than maintenance is very less compared to DC generator or DC motor. That's why AC motor, AC generators are nowadays getting popular. From that power unit, correct? Then you have battery, correct? Accumulator, it can be a battery or super capacitor. Please note that you not necessarily super capacitor, it can be a battery or super capacitor will be used for storing the electrical energy so that then it drives the wheel. Please, here it shows the two motors. It can be single motor also. Need not be two motors. The series, that means there's a motor. Can be single electric motor or two electric motor driving at two wheels. This is one type of series electric. But main thing what you have to note, the engine is not driving wheels. Wheels are driven by motor. Engine job is to produce electricity and charge the battery or drive the motors. So this is called series hybrid. Instead of two motor, it can be one motor also. Then it can be directly going to wheels from the electric motor using gear arrangement transmission system. Okay, what is advantage series hybrid? Please take the points, layout, all the things. That's why, because exam. Again, I always say exam. Every class, not only you, for even BTech, since I 2003 I was teaching. Sir, I did not take notes. I want slides. This is not well. I am flowing note. Please take. In exam, it is expected. In exam, you need to write these important points. Also, certain points I am explaining. Correct? I say draw the configuration series hybrid. Correct? They call functional block diagram and explain how the series hybrid works and tell the advantages. Series hybrid, I am telling a engine is driving from the engine, then your generator gets the power. That power is going to the inverter, converter, which converts the power into DC or AC. It charges the battery and also supply. From that, the power is coming from battery, it drives the electric motor. Electric motor in turn is connected. Like that, you have to write. Briefly explain working a series hybrid and also tell the advantages. So again, I am telling already you have done 1 or 2 courses, my courses, so you know what I expect. Just not showing this one and just bulleted points of what I'm explaining. Also, you have to write as a paragraph. Just write the bulleted point. Sir, 5 marks you gave, 2 marks means I will give only that much. Because I am explaining, right? Apart from the points shown here, I am also explaining. That also you have to write. Explain means you have to write, not taking just bulleted points. Okay. So series hybrid has been referred as a range extended electric vehicle, as I told you. Internal combustion drives the electric generator, which in turn turns the electric motor. The electric motor can be single or motors coupled to vehicle wheels through proper transmission system. Correct. Then batteries are used as energy storage, and generally there is no need for transmission system, gearbox, and differential in case of this kind of series hybrid, because you are driving the wheels directly from electric motor. And already told what is the advantage of electric motor. I told why the gearbox is needed. I told yesterday, explained many times. Correct. So this is a dead weight. Gearbox, differential, transmissions, all these things are really. That's why in some vehicle, what they put in a series hybrid, they will attach the electric motor directly on the wheel. No, not even transmission. Correct? Like a wheel up motor, no, in use of the two-wheelers. Some electric car system, they, for example, if you have 100 kilowatt power, this will be 50 kilowatt, this will be 50 kilowatt. Two motors directly attached to wheel. From here, there's no mechanical. Please note the electrical wire only. Correct? That means lot of gearbox is not there, transmission is not there, unnecessary mechanical, heavy, everything is removed. From this one, battery, inverter circuit, from that electric motor on wheels directly driving. Correct? This also some vehicle manufacturers are trying to implement. It's if I have a single this one, then you have to give differential, all those things are needed. Correct? So this is also another possibility. That's what you can reduce. Advantage of this is this. Okay. What are advantages? The great advantage, IC engine only operates at optimal condition. I told you it is a hybrid vehicle, correct? But it is looks like an electric vehicle. Electric motor only is driving. And now IC engine, normal vehicle, the engine speed varies from 0 to, for example, 6,000 RPM. In a 4-cylinder, 6-cylinder engine or 7,000 RPM. Single cylinder, it can go to 10,000 RPM. Correct? Motorcycle, all those things. So it is variable. We know that the power torque curves are varying. At low speed is very bad. Correct? Only for this one. So, but we know that if I operate this engine at 3,000 RPM, they call max torque condition. 3,000 RPM. So the engine will be driving generator at 3,000 RPM. Always will be driving. Engine speed is not very optimal condition. So the fuel efficiency, thermal efficiency, all this are maximum. So engine drives the generator. Generator also operates at peak condition and charges battery and drives. So that means optimal, this one. Maximum efficient thermal, that is the advantage. Pollution also less. Maximum thermal efficiency, least pollution, or max torque condition. The pollution will be engine ECU sees that the maximum fuel is burned, maximum torque is available, maximum power, and less pollution. Mid torque condition. This is a mid torque condition. The emission will be at 10 to 20 times lesser than low speed or high speed. Correct? So that is advantage. The higher fuel efficiency, less emission. Engine can be turned off when battery is fully charged. Correct? We know that this is a battery. The engine can be this one. It can drive. Please note that the engine drive the generator. Generator power can charge the battery, also driving the motor. Okay. Now, if the battery is charged fully, this engine can be switched off. Power can be drawn from here. So that means pollution can be reduced. Okay. That is the advantage of series hybrid. Okay. Controlling the final control is the electric motor. Please note that finally, vehicle is controlled by the controlling electric motor. Controlling electric motor speed, torque, all the power, all this thing much easier than controlling IC engine. Correct? So variable speed IC engine in conventional engine. So that means the control system is easy. Implement a control system for control electric motor compared to IC engine. Fuel efficiency, less emission, and most of the time engine operates at mid throttle. So that is advantage. Next one is what you call a parallel hybrid. Okay. Parallel hybrid configuration already we saw. This is a functional block diagram. You have a battery. There's a converter, correct? DC to AC or DC to DC. Depending upon what motor we are using, whether you are using DC motor or AC motor. We will see when we talk about it. It can be anything. Correct? So it may be BLDC or induction motor. Induction motor, you need AC power. That means from the battery, which is DC, it is converted to AC voltage. If it is a BLDC motor, DC voltage converted to DC voltage. Battery voltage can be anything starting from depending on type of battery. Correct? Lithium-ion battery, the battery pack power voltage can be 400 volts, 300 volts, 600 volts, 500. The battery pack can be maybe start from 300 volts to 600 volts battery pack. Okay, and it can provide, for example, 200 amps to 300 or 400 amps, depending on. So power equal to P equal to V into I. Correct? If I say the 300 volts and 200 amp, because it is going to be 60 kilowatts. Correct? The motor power. So from here, the power converts from this low voltage. For example, your battery pack is 300 volts, your motor is 600 volt motor. Please note that it can be 600 volt. Why it is when we talk about motor, I will tell you. Okay, so that means 300 volt battery power should be increased to 600 multiplied. So in that case, I may use a DC to DC converter. The job of that DC to converter, battery voltage 300 will be amplified to 600 volts, supply the electric motor, because I have a motor which needs 600 volts. Sometimes I may have a battery pack 600 volts, but motor is 300 volts. Correct? So I cannot supply the 600 volts battery power direct voltage directly on electric steering, motor will burn. So that means it should be stepped down. So that also will be done by DC to DC converter. Stepping up, stepping down of the battery voltage to appropriate voltage of the DC motor is done by DC to DC converter. Similarly, if I have a AC motor here, then I have the converter will be DC to AC converter, which is called as inverter. DC to AC converter, other name is simply called an inverter. If somebody says inverter, that means battery voltage is DC voltage, the output is a AC voltage, and you have AC motor. I have AC motor which is driving my vehicle. That means I need AC voltage, but my battery is a DC voltage. I use inverter. Inverter takes DC voltage, converts into AC voltage, appropriate voltage supplies to motor. That is called DC to AC converter, which is also called as inverter. Other one is I have a DC pack and I have DC motor. Correct? In that case, it is called as the DC to DC converter. Note down. Suppose if I ask a question, all these things point you have to write. I am expected if you want to be S grade or A grade. Correct? So that's why I'm explaining. You have to take points, all those things. While writing appropriately, you have to form under this one. I cannot give like this one. Okay. So depending upon type of this one motor, if it is a DC motor and you need DC to DC converter, and that also needed when you have the battery voltage is different than the motor voltage. Okay. In that case, we need. Okay. Then of course the current should be controlled, power should be controlled. All this thing we'll see when we talk about motor controllers. So in parallel hybrid, I have this one. Okay, this one thing. Other one is I have an engine with a petrol fuel tank. Reservoir is nothing but fuel tank. Correct? Engine can be a gasoline engine or a diesel engine. Okay, depending on type of fuel, petrol or diesel will be there. Fuel comes, it drives. Please note that in parallel hybrid, both will be operating. Motor will be running, simultaneously engine also will be running. How much power? I need 100 kilowatt power on the wheel. So whether this will give 50 kilowatts, this will give 50 kilowatts, or this will be 60, this will be 40, or this will be 60, this may be 40. Correct? That varies in parallel hybrid power. Correct? So depending upon design, fuel efficiency, all those things matter parallel hybrid. What is time now? 6:50. Okay. Now, parallel hybrid, this will be my last slide. Remaining will continue tomorrow. Both internal engine, IC engine, and as well electric motor is connected to wheels through a transmission system, gearbox with clutch mechanism, all these things. Correct? It has to share equally. When sometimes you may drive only with electric motor, sometimes you may drive with the engine, or combined hybrid vehicle can do both. This, correct? Only engine, only this one, both together at different percentage. That depends upon design. The two power sources is connected to a differential proper mechanism. The torque supplied must be same, and the speed is added up, and the exact ratio depending upon differential characteristics. And when only one one of the two sources being used, other sources still supplying some part of the clutch fitted with a reverse one-way clutch for automatic clamp mechanism. How whether one around work, both will work. When one is working, other may be idle or completely switched off. At different ratios, power can be supplied to the wheels from the both resources. That's what we are talking. I stop here. So this is called power split hybrid. Next version, we'll see it from tomorrow. Thank you. Please give your attendance as a chat message before leaving. Any questions?
Sir, any examples on the remaining type of hybrids? Like we discussed about, I think Honda City, like I think Amit and Roshan has pointed out. But any other examples for any other cars?
We will talk maybe tomorrow. Okay, definitely tell some examples.
Sure, sir. Sure.
Toyota Camry, you can refer the first electric vehicle in that sense, hybrid vehicle in that sense.
Prius also is there.
Prius.
That is the first one, very popular. They are selling like hotcake for last 15 years. In US also so many. Hybrid means they say Prius only first because it is there for a very long time.
Yeah. Prius is very popular. Yeah.
Yeah, very, very popular because I've been to US for now. I told you many times visit as a visiting professor. I see Prius. The other companies are just talking, they release. And it is the most successful hybrid vehicle compared to any other vehicle in the world. We will see tomorrow. Thank you. Please give a chat message. We'll see you by 6 o'clock tomorrow. Thank you.
Sure, sir. Thank you. Thank you.
Okay.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you. Take care.
Thank you, sir.